All right. Right now we want to talk about operations on logarithms. Operations are adding, subtracting, multiplying, things like that. So we have two different scenarios. Kind of like before when we talked about can you go from exponential form to log form or log form to exponential form. We're also going to look at a series of logarithms, either expanded out or condensed in. I learned it as condensed, but now it's kind of changed, and the directions instead would be to write as a single log. So the question would be, could you go from one to the other? All right, so here are three rules, and we'll do some practice in a second. These are expanded form. These are condensed form, or written as a single logarithm. Although I'm used to condensed, I really like the directions write as a single logarithm because it kind of tells you pretty obvious your answer should have one log, not two. Just a single log in your answer. Now, these are based on the rules for exponents. And one of the things I mentioned in class, I'm going to write it down here for a second, is that, for example, when I write 5 to the second power equals 25, in log form, I write that as log base 5 of 25 equals 2. In other words, in log form, I have solved for the exponent. 2 is my exponent, right there. 2 is my exponent, and when I write it in log form, I've shown that a logarithm is equal to an exponent. So we are going to have to use the rules for exponents to apply with logarithms. When I am adding two logs, it's like I'm adding two exponents. And when did we add two exponents? When we had the same bases, and these had the same bases, and they were being multiplied. When the same base was being multiplied, you added the powers. So that means if my logs, or exponents, are being added, I must need to multiply. So those two go hand in hand. If I want to write it as one log and they're being added, I'm going to take the 6 and 7 and multiply them and get 42. So that would be the same thing as a log base 3 of 42. All right. Now, when I am subtracting logs, well, when did you ever subtract powers? When you were dividing. So I'm going to take the 24 and 4 and divide them. Write it as a single logarithm. So I'm going to write log with a base of 3, it stays the same, but I'm going to take the 24 and 4 and divide them. So 24 divided by 4 is 6. My final answer is log base 3 of 6. Now, I'm going to start actually on this side. When you're multiplying, you add the powers. These powers are being added. When you divide, you subtract the powers. When you raise a power, now look at this, log of x is an exponent. A logarithm is an exponent. So this logarithm, this power, is being raised to a power. What do you do when you raise a power to a power? You multiply, okay? So when I'm raising it to a power, it's the same thing as multiplying. The log of x to the 5th power is the same thing as the log of x times 5. So these are equal to each other. It's very rare that you can say that when you raise something to the 5th power.
Mr. Dravis, please call the front desk.
Sorry.
28001. Mr. Dravis, please call the front desk.
Okay.
28001.
All right. So it's kind of weird to say that when you raise something to a power, it's the same thing as just multiplying it, but it works for logarithms. Now, the hard part is, I mean here, when you have 2 or 3 or 5 logarithms, and the directions say write as a single logarithm, it's kind of obvious what your answer is going to look like. It's going to look like one logarithm, and then you just have to remember what to do. So if you start here, you know that your answer should be 1 log. You start here, you know your answer should be 1 log. The problem with the last one is they are both 1 log. So if I see something like this, and the directions say expand, I'm not sure sometimes if I'm right and I can leave it alone, or do I move the 5 up? Basically what happens is this 5 can get moved up there to a power. Or this 5 could get moved down, forwards or backwards. So sometimes it's easy to forget which way it goes. Okay, do I leave the 5 in front or do I put it up as a power? Which one do I have to do? Because it's hard sometimes to remember which one's an expand solution or answer and which one is a single log format, I guess you would say. So I use Dora the Explorer to help me remember. Remember swiper, no swiping? Well, just if you think of the phrase, expanding, no exponents. Expanding, no exponents. So when you're expanding, you should not have an exponent in your answer. Something to remember. So let's try these. I am going to practice some with you. I'm going to use a different color though. I'll use blue. All right, write as a single log. So my answer is going to be a log base 2. Log base 2. That part was easy. Now, I'm adding, so what do I do to the values? I multiply them. When I'm adding, I multiply those values. So 5 times 3 is 15. This is equal to the log base 2 of 15. All right, log base 7 of x minus log base 7 of y. What do I do to the values? I divide them. So my answer is a single logarithm with a base of 7, and I take the x and y and divide them. All right, try another one. Uh-oh, number 3 has a 2 in front of it. I'm writing as a single log. I'm not expanding, okay? So I want exponents. Expanding, no exponents, but I'm not expanding, so I want exponents. I want that 2 up there as a power. I'm going to put the 2 right there. Oh, there's a 4. I want that 4 as a power. Now I can add, write it as, let me rephrase. I cannot add a 2 log base 3 and a 4 log base 3. I can't put those together. So what I need to do is I need to get the 2 and the 4 out of the way. When I have a log base 3 and a log base 3, I can now do my operations. I get a single logarithm, base 3, and I have an x to the second and a y to the fourth. I'm adding, so what do? I multiply those values. There you go. That's all you have to write. Okay, let's try this one. Ooh, this one has 3. It has, oh, this one has a 2. So I'm going to put the 2 back up as a power. Because I'm not expanding, so I want the power. All right, I have a log, and it's going to be a base of 5. I have an a minus a b, the log base 5 of b squared. The minus means I divide, so I put the b squared on the bottom. But I'm adding log base 5 of c. So that means I multiply by c. So the c goes on the top. And that's my answer. Now if those were numbers, I could reduce them maybe, but they're just variables, so I can't. So that is writing as a single log. Now we're going to flip it around and do the opposite. All right? I'll use the maroon. I want to expand. I want to break it apart into multiple logarithms. Here we go again.
Christina Moore, please come by the front office. Christina Moore, please come by the front office.
Okay, I'm going to have more than one log. I have an x times a y. When you multiply, what do you do to the powers? You add them. So this is going to be a log, don't forget that it's a base 4, of x plus a log base 4 of y. And so I separated them into 2 logs. Number 6, I have an a and a b, so I'm going to have two logs again. One is going to be a log base 7 of A, and one is going to be a log base 7 of B. Since I was dividing, what do I do to the logs? Subtract. Oh, here we go. This one I'm going to have to probably do in a couple steps. I have an x squared and a y cubed. So my first step would be that I have a log base 5 of x squared and a log base 5 of y cubed. They are being multiplied, so I add them. However, here comes our little Dora. Expanding, no exponents. I cannot have exponents in my answer because I'm expanding. So what do? I drop them down to the front. I bring this 2 down and make it 2 log base 5 of x. And this 3 has to come down, and it's a 3 log base 5 of y. There's my answer. I know, some of these are really weird. Once you practice and you get the hang of it, it'll make a lot of sense to you, I hope. All right, this is the one that messes up the most people. You have an x and you have a y, but you also have a times 2. That 2 is a third value. That 2 is a third logarithm. So I'm going to have 3 logarithms. My first one is log base, where's my base? Is 2 my base? It is not. I have no base. What is it supposed to be then? It's an understood 10. Remember, when there's no base, it's an understood 10. Do I need to write a 10? Nope. I don't even have to. If you want to, you can. You can write a 10 down there if you want. But it's just log of 2. There wasn't one to start with. You don't have to write it. I have a log of x. And I have a log of y to the 5th. They are all being multiplied, so they all are being added. Am I done? Close. Expanding, no exponents. I have an exponent. I got to get rid of it. So my final answer in expanded form is log of 2 plus log of x plus, bring that 5 down, 5 log of y. All right? Okay. Some of these can get a little bit more, maybe complicated is the word I want to use. Maybe just have a little bit more to them that you have to deal with. But overall, these are the basic rules. There's mainly the 3 operations that you have to deal with. Good luck. All right.